only have 2 of these to go over, and then you guys can work on your multiple choice. All right, so the first one says a polling agency is investigating the voter support for a ballot measure in an upcoming city election. The agency will select a random sample of 500 voters from one region, Region A of the city. Assume that the population proportion of voters who would support the ballot measure in Region A is 47. What is the probability that the proportion of voters in the sample Region A who support the ballot measure is greater than 50? So how do we do this? First of all, what's it asking me for? What's the question? What's the probability? So we're going to write a probability statement. The probability that what?
That proportion of voters in Region A is
Greater than 50, right? So how do we do this? Anytime you say proportion, you should know exactly what to do, and it's going to be in your calculator, and it's perfectly fine. What do you got to do? Take a guess. No, that's to find your z-score. Like if we had a 95% confidence or whatever, but you're close. Come on, guys. Normal CDF. Okay, so anytime you're looking for probability, you're using that normal CDF. It's CDF because it's greater than. Okay, if it's equal to, it's going to be PDF. So before we do that, though, we need to make sure that we check conditions to make sure that it's normal so that we can use normal CDF. Okay, so what conditions do we check?
I have a quick question.
What?
Do we need to bring our own calculators to the exam?
I think we give them to you, but I'm not sure. Yes, you can bring your own. Yeah, if y'all don't bring your own and they say, oh, you were supposed to bring it, just come down here and get one. It's not gonna be a big deal. Okay. All right. So we're going to do normal CDF, but we got to check conditions first. The first condition is that it's random. Is it random?
Yeah.
Yeah, it says a random sample of 500. Then we check what? 10%. So how do we check that? Good. 10 times your sample size. Do we think that there is more than 5,000 voters? Yeah, so it passes that. And the last thing we need to check is normal. And you guys can just write normal. You don't have to write large counts or anything like that so that you don't screw it up. Just know that if you're doing proportions, which is what we have, that's going to be your NP and N1 minus P. Okay, so we're going to check NP and N1 minus P. And NP is 500 times 0.47. And this one is 500 times 1 minus 0.47. And that's all you have to write. What do we need to make sure that they are? Greater than or equal to 10. And they are both greater than or equal to 10.
Okay, which one's 10 and which one's 30?
Which one is which? Proportions are 10. When would it be 30? When you're looking at what?
Is it sample size?
It is sample size. Your large sample. Okay. Is everybody good?
Sample size is 30 and proportion is 10.
Yes.
Okay.
Okay. So then we're going to do our normal CDF. Make sure that you write it all down. When we do that in our calculator, we're going to second bars, normal CDF. What is our lower if we want greater than or equal, greater than 0.5? What's your upper going to be? Okay. What about your mean?
It'll stay the same.
What stays the same?
Mean and standard deviation.
Is not 0 and 1. Why is it not 0 and 1? When can I use 0 and 1? When I do what? standardized. So I would have to find the z-score to use 0 and 1, but we don't want to do that because we're too lazy, and I don't mean that in a bad way. I don't want to find it, so I'm not going to do it. Okay, so this way I can just use the values that I have. So what would my mean be? What do you think? Say it again. Where'd that come from? What's your mean going to be? Not quite. It is the 0.47. It is your proportion. So your mean is going to be equal to your proportion, which is 0.47. And then the last thing I need is my standard deviation. And you have to remember how to find this standard deviation. So can you remember how we do that? It is a formula. What do you think we should have in that formula? So what? Okay. How do I do that? Ooh, big fat square root. I like that. Not NP, but P 1 minus P over N. Okay, I'm gonna go ahead and put that on there. Yes, it is on the formula sheet. 0.0223. That's a really big, weird 3, sorry. So 0.0223. When we put this in our calculator, we get 0.089. And that's it. Let me see if I can show you guys. Just bear with me, Zoomers. It's okay. I'm okay with it. They may be taking the test. Hold on, I think I passed it.
Is that the exact same sheet that we're on?
Yeah, it's the exact same one. I don't know if it is on there or not. I do. Oh, there it is. There it is. Right there at the very bottom. Sorry, I just didn't scroll down far enough because I thought it was, but so right there. Good. All right. So then there's your other one, the one that you guys were thinking about, the N times P and then the NP1 minus P, but we're not using that. We just have the proportion. Okay. Is everybody good? All right. So I'm going to go back. I'm going to stop sharing this and go back to my other share. All right. So now it says the polling agency will take another sample from a different region, region B of the city. The agency plans to select a random sample of 400 voters. Assume that the population proportion of voters who would support the ballot measure in region B is 0.51. Describe the sampling distribution. This shape, center, spread. If there happen to be any outliers, then we're not going to have any because it's going to be normal. But it doesn't matter. It doesn't talk about outliers, so we're going to leave it alone. So when it says describe, you want to do shape, center, and spread. Okay. So we want to start with center and spread because we already know the formulas. Okay. So how do I find the center? And remember, it's the difference in the sample proportions, region B minus region A. So your mean of B minus A, how would I find that? What was your mean of A? 0.47. So what was your mean of B? Good. And we get 0.04. All right. So remember, differences when we do standard deviation or variances, are we going to use a subtraction? Yes or no? No, remember we always add those. Okay, so basically we're gonna add those and then put it underneath the square root. So the standard deviation is gonna be a big fat square root. You're gonna do A. It doesn't matter which one you do first because we're not subtracting. 500, you're gonna add. We have 0.51, 1 minus 0.51, but this sample size was 400, which gives you 0.0335. And then how do I do the shape? What's the shape of A? How'd you know it was normal? We did the normal test, right? So we're gonna do the same thing for B. So A is normal. Via part A. For B, we have to check the normal condition. So that was NP and N1 minus P, right? What's your N for B? 400. Times our P was 0.51. And we're going to do 401 minus 0.51. And both of those are greater than or equal to 10. So it is also normal. If your two are normal, the difference will also be normal.
You have to like actually write anything out loud or
Just test it to show that they're normal and that's fine.
yeah, but like so you would have to write like a whole paragraph.
The actual, let's see what it says. To get an E, you state that the sampling distribution is approximately normal and verifies the sample sizes are large enough. We did that, normal, large enough. Correctly determines the mean of the sampling distribution. We did that. Correctly determines the standard deviation of the sampling distribution. Got it? Everything does not have to be written out as long as you answer the question. Now, would you kind of CYA if you do it? Absolutely. You know what I'm saying? All right. What's the probability that the two sample proportions will differ by more than 0.05? So what is it asking for? Probability that the difference is their difference, right? They differ. What's this say? Greater than 0.05. And we're talking about their difference here. So we're looking at what we did in part B, okay? So we're going to use our normal CDF again. Why can we use normal CDF? It's probabilities, and we've already checked to make sure it's normal, right? So we've already done that part. So what's our lower if we want greater than 0.05? 0.05, what's our upper? 10,000. What is our mean? Say what? You sure? We're talking about the mean of the difference. What is it? 0.04. And then what's the standard deviation of the difference? Yeah, we already did this. That will give you a probability of 0.383. Indicates the probability that is being computed with either a correct probability statement or a picture of the normal distribution with the shaded region. So this is your probability statement. All of this is fine. This one, everything works. Everybody good? You got it? All right. So that's your Unit 5 free response. Unit 6 only had one as well. It actually had two, but we've already done one of them. All right. So Unit 5 is done. All right, Unit 6. It's only this very front page, and it's one of the basically state plan do concludes, okay? So a random sample of 100 people from Region A and a random sample of 100 people from Region B were surveyed about their grocery shopping habits. From the Region A sample, 16% of people indicated that they shop for groceries online. From the Region B sample, 24% of the people indicated that they shop for groceries online. At the significance level alpha equals 0.05, do the data provide convincing statistical evidence that there is a difference between the two regions for the population proportions of people who will shop online for groceries? Complete the appropriate inference procedure to support your answer. So this is graded in a lot of parts based on your state plan do conclude, okay? So lots of different parts are graded here. So let's start with our state. What do we need to have in our state? Okay, so our alpha, which is 0.05, our null, and our alternative. So what's our null? No difference. You can write that two different ways, and I'm going to show you both. P of A minus P of B is equal to 0, or you can do P of A equals P of B. There's no difference. It does not matter which one you use, okay? So then if you do your alternate, it will not equal 0, or they will not equal each other. Again, both of them are the same thing. There is one more thing that you need to have in here. You have to define them. What is PA and what is PB? So PA is oh, you can't just say Region A.
100 people.
Nope. The proportion of people who shop online for groceries in Region A. You have to say it all. Okay. So the proportion of people online shop Region A, and this one will be Region B. So they're going to be exactly the same. So there's your state. What do I need in the plan? What kind of test am I doing? In a minute. Which one is it? Why is it a Z test? It's proportions. Good. Good job. 2 sample Z test. You get credit for writing that. If you do not write that, you lose credit. Everybody got that? All right. And then we have to do what? What'd you say, Emma? Check conditions. What are our conditions? All right. Random. Is it random? Why? Stated. 10%. What do I do for 10%? And I should do that twice because I have 2 samples. And then our last one is what? You can do either one you want to. I just write normal just because that's what we're checking. This is the weird one. This is the weird one. All right. So for your normal, you actually have to use the combined. Do you guys remember doing that combined, P hat combined? Yes. All right. So we had P hat combined. You're going to do your sample size times your proportion. The first one was 0.16 plus your sample size times your other proportion, which is 0.24. It was basically your proportion plus your proportion over your sample size, plus 100. Okay. This gives you a p hat combined of 0.20. So to check your normal condition, if we're doing region A, we're doing the sample size of A times your p hat combined. Again, your sample size A, 1 minus p hat combined. You'll do the same thing for B. And remember, they're both the same sample size, so you're going to get the exact same answers for these. Exact same answers. So the first one would be 100 times 0.2, 100 times 0.8. This one would also be 100 times 0.2 because both sample sizes were 100. And then we know it's normal because they're all greater than or equal to 10 because it's 2080, 2080. Is everybody okay so far? Why do we do the 10% rule? We do the normal to make sure it's normal. We can use normal CDF, normal everything. We can make it good. Wow. What about the 10% rule? So that we can do what? You are correct. It's a test for independence. What does it allow us to do? Find the what? Think way back. It allows us to be able to find the standard deviation. Okay, so we need to find our standard deviation. How do we find our standard deviation of this? What do you think we should start with? Big fat square root. That's a great idea. Big fat square root. This is combined, right? There's two samples, so it's going to be a plus. Okay. How do we do that last one? What proportion am I going to use? What proportion am I going to use? Your 0.20. Your 0.20. So we're going to do 0.20, 1 minus 0.20. Our first sample size is 100. You're going to do the same thing. And if it is a different sample size for B, then you would use the other sample size. These just happen to be the same. And we get 0.0566. And that's pretty much your plan. What are we going to do in the do part? What do we do in our calculator? Not the sample. What are we using? If we look, you see our two sample. Yeah, you see our sample, it's got 2 standard deviations. How many standard deviations do we have? Just 1. So that automatically tells you we're not using that. So go through again, stat, test. Here's a 2 sample z-test. We said that one didn't work. Here's a 2 proportion z-test. Do we have 2 proportions? Yes, we have 16 out of 100 and 24 out of 100. We're trying to figure out if it's not equal. Okay, P1 or PA is not equal to PB. So I'm going to write that down. 2 prop z-test. And we have x1 equals 16, n1 is 100, x2 is 24, n2 is 100, and not equal to P2 is what I'm going to use. So that when I calculate it, I'm going to write down all of those, except for I don't have to write down P hat 1, P hat 2. I really don't, but if you want to, that's fine. So again, just to make sure I get it all correct and I get all parts of it, I'm gonna write everything down. So that if it has any doubt about where I define my variables, there they are. How do we conclude? Okay, our p-value was, oh, I didn't write that one down, did I? 0.157. Okay, so 0.157 compared to our alpha, they said was 0.05. What do you know? So what do we do? Fail to reject H sub O, which means we do not have convincing evidence. And then we go back up to the top that there is a difference between the two regions for the population proportions of people who shop online for groceries. Got it? So go all the way back up there and write all of that. All right, so here's how they score this, and I just want to explain to you how they do it. Scoring step 1 is make sure that you have the appropriate test and the appropriate hypotheses. So it says the correct test is identified, the null and alternative hypotheses are stated correctly, and content is explicitly stated or is implied through labeling of variables. So right here, these 3 things is what they want. Got it? All right, part 2 is conditions and calculations. To get essentially correct or full credit, the 3 conditions are checked. The correct test statistic is computed. Does not matter where that's at. So remember, your test statistic is this one down here. That's on the page. You are good to go. Okay, we didn't do it in the second part, but it's on there, so we're good. A p-value consistent with a computed test statistic, we have that, so we're good to go on that one. All right, we flip it through. Part 3, essentially correct. If you explicitly compare the p-value at the significance level, you have to write that. You have to write it. Otherwise, you won't get all that. The correct decision, that's this one. And then the statement in context gives you all your credit. Got it? Is everybody good? All right. I'm going to stop sharing, stop recording.